Hello, everyone. My name is Piers Ridyard. I am CEO of RDX Works, and I'm here with the founder, Dan Hughes. We are doing another session of AMAs. We haven't actually had so many recently in the community. As always, if you want to ask us a question that we'll cover, just go into Telegram, ask a question, and flag it for AMA if it's something you think would be an interesting discussion for me and Dan to go through. Always happy to do that. I'm in a slightly different location today because I've managed to get the COVID, so I am isolated away from everyone else at the moment, which is why it's slightly different. But Dan has got a nice new 4K camera, so that he looks in nice 4K detail for us.
It's for the Board Clock Club.
It's for the what?
The Board Clock Club.
The Board Clock Club.
Yeah. Do you not know what the Board Clock Club is? Mind you, you've had COVID, so you probably don't.
I know what Board Yacht Club is, but I don't know what's the Board Clock Club.
So a few nights ago, I left a Cassandra test running where I was uploading the stream, and other people could view it. And then I went home for the night, and I thought I need some way to kind of show that this is like a real stream. So I grabbed the office clock and put it on the chair, and then left like a drum and bass mix running on the speakers, so you could hear it, you could look at the time, you could see that it's real because the clock was ticking, and it's kind of become a bit of a meme now. So I'm now collecting clocks to put here when I'm not in the office. I bought one with an almost 4-foot diameter yesterday. It's huge.
You bought a...
It's a massive fucking clock. So it's just going to be here, like a massive clock to see.
That's amazing. That's amazing.
Just a bit of fun.
I want to see if I can get you like a Salvador Dali like melting clock that actually works. That would be
amazing. I'm just going to have loads of clocks, like some weird time machine inventor or something, just hanging around the office everywhere.
Alrighty, so we've got some questions that we didn't cover on a previous one. Which I'm going to go through, and then like a couple of questions that I've pulled out from sort of more recently as well. So this question is by Sourena, and it reads as follows. So the Cerberus infographic reads, the membership of each validator set shuffles periodically called an epoch. Considering that in the future, huge amounts of data will be stored on each shard, and that data is not shared between different shards, does that mean that after each epoch, all data in the network has to be reshuffled? And which algorithm takes care of the minimum number of nodes per shard so that data redundancy and decentralization is always guaranteed?
Okay, so on the first piece of that question, just shuffling the data. So actually, each shard will only have a small amount of data. It will have like a up when something is created and a down when it is used, destroyed, whatever, right? So I've got 10 XRD. There's an up somewhere that says that this XRD is owned by me and it's not been spent. And then when I spend it, then that goes down into a different state that says this is now spent. So that's basically all each shard is going to store. There may be some kind of ephemeral transitional stuff in the middle for like, contracts doing complicated things, but generally that's all that's going to be there. So they're quite small. But what your validators are doing, each set of validators is responsible for a subset of all of the 2 to the power of 256 shards, right? So if you've got 10 validator sets, then each validator set is responsible for 1/10 of all the shards. So to try and avoid confusion at the moment, I'm calling them shard groups in terms of validators. I mean, there's probably a better term. But when people are asking about shards and then validator sets, and then there's a confusion sometimes around like, is a validator set a shard or what is it? Because you've got so many shards, then that's how I tend to do the distinction. So in the case of that question, let's say you've got 10 sets of validators. So you've got 10 shard groups, and each one of these shard groups is serving 1/10 of all the shard space, right? Now, what you want to do is you want to churn some validators out of each one of these groups occasionally, just in case, some of them are malicious. Eventually, they'll get cycled out somewhere else, right? So what's actually shuffling is the validators and not the data. The data just stays where it is in the space, right? You don't move it from one shard to another. Instead, you adjust the shard groups, and the shard groups are adjusted by adding and removing validators. So obviously, if I'm being churned out or being churned in to a particular shard group, then all of the state that I had from my previous shard group, I can either keep it for redundancy if I really want to, or I can prune it, get rid of it, because I have to synchronize with the current state over in this new shard group that I'm going to. Now, in the worst case, that's going to be I'm going to be synchronizing a tenth of all ledger states, right? But there are obviously some tricks. Things get stale. Things that have been consumed already. Maybe I don't synchronize them, or I synchronize them last. So even though I'm potentially going to be synchronizing a large amount of data here because it represents a tenth of the network, I can optimize the way that I do that. I can say, well, okay, just give me all the current active stuff that's in an upstate first, and then I'll synchronize all the rest later for data redundancy and all that kind of stuff. So yes, so I get cycled out somewhere else, and then I have to synchronize with the new group that I'm in. And yeah, there's a bunch of different tricks you can do to make that more efficient. And what else was going to think? Something else I was just going to mention as well. And so we don't cycle out too many at any point in time. So like a small portion will get cycled out and cycled in, but then over a number of epochs, you've got a completely new set of validators within that group. So you can be sure that anybody who is faulty or not reliable or dishonest, adversarial or anything, they've disappeared somewhere else. And it also means that if you happen to get, say, some collusion between different validators, that you can break that collusion as well. And then the second one, which algorithm takes the minimum number of nodes. So obviously,
so to be clear on that, just for a couple of follow-up questions, you're saying that over some time n, there will essentially the entire network will be resynced every period, depending on like how much of a validator set you are periodically sort of syncing out, shuffling in an epoch. But you would never actually shuffle an entire validator set out of a set of nodes. You'd only be shuffling out a subset of those, which means that when whoever's being shuffled in has got plenty of peers from which that they can sync up the data from, so that they can get back up to speed to be able to participate in consensus.
So like if you had 100, maybe you don't want to cycle out any more than 10 per week, right? Because then if you have say you cycled out 10 live validators, and say a large portion of who's remaining are not live for whatever reason, they're offline at that time or they're having issues and stuff. There's still plenty of redundancy for you to be able to get the complete copy that you need, right? So you would only do small numbers at a time. So yeah, the second question about the decision process on shuffling these sets. So this is kind of like a long research path that I've been looking at for quite some time. Different ways to do it, more efficient ways to do it. What works best from a network point of view. So obviously you want to have kind of a diverse set of validators in a group. You don't want to, I don't want to shuffle someone out and then shuffle them back into the same group and do that a lot, because then if there was any collusion there or whatever, I've only shuffled it out, say, for an epoch, right? But you also want to make sure that you're not pulling somebody into a group that can take control of that group. So let's say there was a set of validators and they all just had one XRD stake, right? So in total, you've got 100 XRD securing that shard group, but then somebody gets churned into that shard group that has 1,000 XRD. Well, they immediately just control that group, right? Because their 1,000 XRD that's come in is more than a supermajority of anybody else that's in there. So collectively, everyone's got 100. Say 10 go out, so there's 90, and then I come in with 1,000. It's like, well, I control the group, right? I can set the transactions. I can cause liveness breaks. I can cause safety breaks. Do all kinds of stuff. So what you actually want to do is you don't want to cycle anybody into that group who's got more than, say, 10 XRD, right? But then somewhere else there might be a group where there is a lot of XRD on all the validators. So that guy with 1,000, you can shuffle him in there instead. Well, you can go in that one because everyone in there's got 1,000, so you're not going to control that group, right? And there's always this kind of there's this thing around the security of a particular group. It's like, well, if this group's only got 1% of all the stake that's staked, then that's a security issue. It's like, well, no, it's not. Your security issue matters when that group where 33% or more is controlled by one particular person. It doesn't matter if it's 1,000, a million, or a billion, right? Because for that epoch, nobody can come in and just inject themselves into that group. So I can't just enter that group with 1 million XRD and take control and have to be shuffled in, right? So what matters is that no single actor within that group has got 33% or more of the total stake of that group for that particular epoch. So then you can still, doesn't matter if someone from the outside is, like, some other shard has got billions, the same applies there, right? It's 33%. It's not quantity of XRD, it's a threshold of percent. So there'll be some other group somewhere where you've got 100 validators with millions of XRD each, and then you'll have some groups where they have less, and etc. But ultimately, what you want to do here when you shuffle in and out is that you want to make the quantity of XRD that's within a particular group fairly flat in a perfect world. Obviously, you'll have some variations, but you don't want those variations to be too peaky and troughy between the validators. Otherwise, then you'll just promote and enable one particular validator to control that set. And so I've looked at combinatorials, I've looked at knapsack, ways to kind of look at the complete validator set with some seed and decide, okay, who's shuffling where based on how much stake is in that group, how much stake they have, how much stake do all the other validators have. And it's quite a compute intense problem. But epochs are fairly long, so we can kind of just run in the background. But it actually turns out that just random sampling is providing results that are almost as good as knapsack without as much computation as well. So just take a set, sample it, kind of brute force, but because you've got a fairly long window of time that you have to calculate this stuff, then it's not critical. It doesn't need to be super optimized. It can just run in the background. And if you've got a big network, then you've got more compute, so you can do some kind of map reduce thing and share the load. And so that's one of the things that's still going on. And there's some fairly basic requirements, which is essentially just you want a particular number of validators in a set, no more than this, no less than that, because otherwise you'll then get message and authentication complexity problems, messages go around, and you want to have some bounds on stake size of the people that are entering the shuffle. So quite clear requirements, and it's just a matter of finding the most optimal way to do it that gives the best results against those requirements, not so much in terms of efficiency of compute, but just how close can we get to meeting those requirements on each shuffle, given a particular set and size of validators with stake and stuff.
That was probably a much more detailed answer than he was looking for, but that's funny.
Probably. Well, there you go. Now you have all the detail.
All right. Next question, which is sort of this is almost, you've almost already answered it. If I hold 10% of stake thereabouts and have lots of validators and simply wait until I get grouped into a shard group with a few of them where I have control, it's not targeted per se. I just wait until I'm in control of a majority vote in one shard group by simple sorting. Say there are 10,000 shard groups and I have 10% stake. I would expect to be in control of the shard group at least once in a reasonable amount of time. Is there a concept of challenging, e.g. fishermen or hidden validators, or is there another guarantee that I wouldn't be able to do a lot of damage, or is my assumption incorrect that I could control a shard group at some point?
So your assumption that you can control a shard group at some point is correct, but the issue here is that at some point, this is the problem, right? So you've got no control over where your validators go at all, because it's a completely random selection, regardless of how the validator selection mechanism works, whether it's kind of a deterministic knapsack or if it's a random sampling or whatever. The point is that is seeded from some mature hash information, whatever metadata that's on Ledger and been there for a while, right? So if you try and manipulate the validator's selection algorithm by manipulating it to get a particular value, you're going to change the seed, which will change the output value. So if you calculate, okay, if I put 10 there, value of 10 on whatever, right? If I can change the seed by 10, then that'll put all my validators in the same place. But by you changing the seed by 10 actually doesn't produce the same outcome that it would. So I've got a hash, right? Say the hash is some value, and I add 10 to that hash. So if I say, okay, got this hash plus 10, that'll give me some output. Cool. But then if I actually then create the hash that has 10 seeded within it, then that actually changes the output, right? So you've got this kind of, it's called pre-image resistancy in terms of hash functions and stuff. So by you trying to manipulate the current seed into something that you think will work for you, will actually change the output to something that you don't want. So you can't inject yourself, right? So you just got to wait. And so depending on how many validators there are in the network as a whole, and how much stake you have, that ultimately determines how long you've got to wait, right? And you have to wait for each epoch to cycle. Now, I'm not going to try and guesstimate based on those variables there, the value in my head, because I'll probably get it wrong and it'll be off somewhere. But I did write a little tool a while ago, because this question comes up all the time. I wrote a little tool. I think it's posted in the Telegram chat somewhere. I'm sure someone can find it, where I ran a bunch of configurations. I said, okay, so with a network with this size and this much stake and blah, 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 and you can change all these parameters. And unless you've got an extremely large amount of stake, like a really high percentage, beyond 10%, you're going to be waiting like months, years, decades, depending on how many validators there are, how much stake you have, etc., etc. The probability of you just sitting and waiting and all of your validators ending up in the same place to give you some kind of influence, where you can control things, like the probability is really really low. And obviously, as you're waiting, the network's probably changing, right? The network is growing, more validators are coming in, more stake is being staked, etc., etc. So your advantage of your 10% stake to start with may not be 10% by the time you actually land somewhere. So you've also got to adjust your own configuration, like how many validators you have, how much stake you have, etc., in response to the network. So there's some logistical effort on your part as well. If you just sit and wait, and a network that has even a small amount of growth, then your 10% won't be 10% by the time you finally end up with all of your validators in the same place. And even if your validators are all in the same place, having 10% of all stake doesn't guarantee you that you're able to control that shard group anyway, because of the way the shuffling puts like for like validators in the same shard group, right? So your high stake validators, where you have 10% of stake, those validators will get bundled in with other high stake validators. So again, you're up against the odds of the network. You're not going to get just randomly placed with your 10% stake into a validator pool where there's only 2% stake, unless you're extremely lucky or you wait a long time. So I'll try and find the results of those tests, because they were quite interesting. It was a little while ago now, so it's probably just buried down in Telegram. But essentially, you need to have stake very close to 33%, and you need to have that spread among a 33-ish% of all validators in the network as well.
Right. So like it's possible, but it's a very long range attack, and it has a relatively low probability of success.
That's the point, right? Is that probability needs to be low. Like all of these systems are it's all game theory. It's all probability stuff, right? If I have X, how long is it until I can do Y?
Right.
And you just got to make sure that the probabilities of such are low enough that it's just a disincentive. So I don't want to wait 10 years to go and all land in the same shard group.
Right. Right.
I can pull off some attack that doesn't net me that much.
Right. And after 10 years, you may have actually, become a very profitable member of the community doing good work for the platform.
Right. And you could have staked, you get rewards and stuff and fees and earnings and whatever, right? It's probably more profitable just to stake that 10% and live off the rewards of it rather than trying to subvert the network and sitting there. Because the thing is as well is that it might be a short-lived condition, right?
Right.
Because when your validators might get churned in, you've gone to bed, and then in the morning, one of them's been churned out. It's like, oh, my tax just passed. I waited 10 years. Why did I have to sleep?
I mean, if they're going to be that sophisticated, they're at least going to write a little bot, right?
Sure, but it's probably a short window as well. Maybe hours tops.
I think the other point is most attacks, and this is something that you have done a lot of sort of work around on sort of long range optimizing for long range versus short range, is that I actually haven't seen any research in this outside of the work you've done, but it seems like most attacks are opportunistic in nature within public ledgers, right? A Bitcoin attack double spend would be opportunistic based on a massive reduction in hash rate rather than someone who's been doing a fork since back in the day that is going to merge at some point. You're like, yes, theoretically that's possible, but that's not the kind of long range attack that you've ever seen on a proof of work double spend. They don't do that. What they tend to do is it's a single block attack, or maybe a 10 block.
The past hour or so of transaction.
Past hour, it's just from the point of view of can I do a reorg that is just past when we probabilistically this exchange says, oh, it's 5 confirmations and I've done a reorg after 6.
Yeah, well, for extracting value if you're a miner and stuff. Oh, there's an opportunity there, so right. I'm gonna mine like crazy,
right?
And then I'm just going to present that, and I'm going to make 50 grand.
Right. So, and most attacks are not actually double spend attacks; they're reorg attacks these days, as well, as you say. Maximum extracted value or minor extracted value (MEV), which happens in Ethereum, that tends to just be being able to shuffle the transactions in a way that's more profitable for you, so that you can take the arbitrage opportunity. And in finality preferring networks, that's a lot more difficult anyway, which is what Cerberus is. There's lots of ways in which what is being described here as an attack vector actually end up being pretty underwhelming attacks for someone to consider, for an attacker to consider. Versus just a healthy functioning network. And that's kind of what you're always optimizing for when you're trying to build these systems.
Yeah, if your long range attacks are difficult in terms of cost, logistics, whatever, then that itself acts as a disincentive, right? So then the only attacks that you have to really contend with are these kind of short range opportunities. People are trying to maximize some short range thing. But that's a different class of attack, right? So there's different ways that you mitigate those. And there's different ways that you mitigate the long term. If you didn't think about the long term, then you'd have long term attacks all the time. So if it wasn't long term strong, then you'd get double spends everywhere. But the fact that the long term attacks are generally costly and difficult to execute and take a long amount of time, or just the resource cost of doing it is very high, compared to the fact that your rewards are generally not life-changing unless you've really managed to engineer it well, and it's destructive to the network as well, right? So you destroy the network that you're attacking. So it's a one-time thing as well. And people are generally they don't want to wait 10 years for anything. Everyone wants it now, right? So if you can make your long-range attacks strong, then no one's going to try them, basically. So it's more of a disincentive as opposed to an actual to something that's going to have to be dealt with in the future. Oh shit, someone's done a 10-year attack. It's like, really? I mean, patience of a saint or what? Like, really, the only kind of people you have to worry about doing these kind of long range attacks are like maybe governments, massive corporations, or whatever, right? And then if you've got that level of resources and that level of dedication to pull off a long range attack, there's probably not much you can do.
Right. The space seems to care a lot less about these conversations than it used to, like sort of maybe four years ago. So it seemed to be like a lot more the nature of the conversations. Like I think sort of like practical approaches to these problems tend to prevail more often now. But like it just does go back to this sort of like a lot of these like questions around attacks come back to the core of like what you're trying to achieve with a decentralized network in the first place. Like if it is truly decentralized, there is always a threshold at which something can be broken, and if you're trying to build something that is optimizing for decentralization, you do have to have some.
There's a point where it breaks.
Yeah, right.
There's always a point where it breaks, and you can chase your tail forever, thinking of ever more exotic ways to deal with these ever more exotic edge cases, and there just comes a point where you go, so you know what? That's enough. If somebody wants to go to all that effort to break it, then fine. Because for normal day-to-day use, this is more than sufficient, except for those kind of crazy black swan events where someone's going to throw $1 billion at causing a double spend 3 months in history. It's like mental.
I mean, to do that, you couldn't even do that unless you were spending $1 billion to get 66%, right?
Yeah, I mean, like whatever it is, right? Whether you're buying hash power, you're buying stake, whatever it is, you're going to be spending billions,
right.
Billions. So you tell me anyone who's that irrational, who's got $1 billion to go to all that effort, when their $1 billion could most certainly make them more returns in a myriad of other ways.
Yeah.
Like, the only reason anybody would do that is because they're pissed off and they're irrational, basically.
Yeah. And I actually think these kind of attacks. There's some interesting work that I think is latent at the moment. But these kind of attacks are actually illegal as well. Like I think that people like purposefully and maliciously attacking a network in a way to double spend, that isn't just an economics game, it is also a criminal action.
Yeah.
And so what you need to have is you need to have someone who has a large amount of money, a large amount of patience, and is willing to conduct a criminal action. It's not just a question
and
of,
it's not like it's easy to hide $1 billion. Hey Frank, where's that $1 billion gone that you had a few weeks ago? Nowhere.
Right. So like the TLDR of this whole conversation is basically, yes, theoretically you could wait with a smaller amount of stake. However, for the average opportunistic attack, it tends towards 33% of stake, and that's the normal bound. There are some probabilities of being able to wait for a smaller amount of stake to give you the opportunity to attack the network. But you are like, then there's all of these other factors that come into it as well. Firstly, that most attacks aren't patience attacks, they're opportunistic attacks of this type on top of these public ledgers. Secondly, that actually you're not just conducting a game theory attack, you're also conducting criminal action. And so like, I
mean, as well, like going back to what I was saying about being rational, with $1 billion, I could severely cripple the banking industry, right? I could go after the infrastructure, how banks talk to each other, where they talk to each other, etc. I could cripple pretty much or severely disrupt any kind of infrastructure, banking, shipping, supply chain. With $1 billion, I can cause a lot of havoc, and I can make a lot of money on the other side of it as well. And like of all the industries, crypto's probably one of like the smallest in terms of the amount of disruption versus gain that I could get if I wanted to be a criminal mastermind. Right, $1 billion will cause a lot of crap for everybody. So, I mean, why would you? If you were going to do something, spend that amount of money to cause some disruption? I probably wouldn't pick crypto to do it. go and nuke some other infrastructure somewhere. So $1 billion, if you're going to be naughty with $1 billion, then you're going to cause a mess wherever you go.
All right, let's move on. Next question. This one's an old question by Mojito Finance, but I think it's an interesting question about regulation. So, is the team prepared for regulations similar to the ones in Estonia, which seems to ban non-custodial wallets? And this is some rules around Estonia's interpretation of VASP legislation and coming in and basically making the creation or use, or seeming to make the creation or use of decentralized platforms illegal and punishable by sort of quite a large amount of fines. This is going to be an ongoing conversation / battle that is going to be happening globally as regulators are trying to find where the happy medium path is. Like their overriding goal most of the time is consumer protection. Regulators' goal is consumer protection, but governments and the goal of governments is a combination of GDP growth and stakeholder response, right? The nation has got a populace, and that populace wants a certain degree of things, and the government is also trying to make sure that their GDP grows. Now, if decentralized finance and Web3 is the biggest innovation to come since the creation of the internet, I actually think it's bigger than the internet in many ways. But the internet has so radically changed human existence to now. And we're going to have the same thing happening with decentralized finance. There is no government in the world who's going to be able to say we don't want that opportunity and that GDP and that growth for our economy and that opportunity for our populace, and to not happen in their country. And there's going to be no population who is going to go, no, I don't want better, faster, cheaper, more choice, greater yields, greater opportunity for my money. But then there's this extra battle in between of consumer protection. How do we create an environment in which the people of a nation can access these products that doesn't take advantage of them, while at the same time not making our country hostile to those kind of companies building in our country and giving that GDP opportunity for our country. So I don't think we have a particular response to it. It's just that it's just more to say that this is the kind of thing that I'm going to. I just think that we need to expect more and more to happen, and that the industry is going to have to adapt in some ways, and regulation is going to have to adapt in some ways, and there is going to be this battle between too much oversight and lack of access versus too much freedom and opportunity for people to be misled, missold, or sort of bad consumer outcome. I think if I don't know Estonia and I don't know the legislation specifically, this is just a tweet. But long term, this is why we're building things like Instapass. Like Instapass is a recognition that AML KYC is going to be necessary, and probably there's going to also be things like more checks that come in from the point of view of a consumer protection point of view, is do you actually understand the products that you're sort of purchasing, that kind of stuff, that will be required by legislation. This isn't because we're saying, oh, I think this is a good idea. I'm pretty neutral on that. It's just that these things are complicated and you need systems in place to help people deal with them so that they can continue to build and continue to innovate. So one of the things I often say internally is Radix should do the difficult things so that the people that build on top of Radix have an unfair advantage in choosing Radix as the home for their platform, home for their project. And this is just us looking forwards and going, right, it seems that MiFID and AML 5D and a bunch of like things that are coming down the line with Mica and stuff like that, are likely to create some challenges for the kind of for people trying to build decentralized finance applications. What can we do as a platform to help people face those battles with the tools they need to do that later on? But yeah, like I think it's good that these debates are happening. And I think that legislation that outright bans DeFi is just not going to fly long term, because it's probably going to be pretty hard to enforce. Like, how do you stop someone downloading a program from the internet and then like generating a private key?
Right.
Like,
how do you stop someone generating a number, basically?
Right.
You can't have that number; it's too long.
You're not allowed that source of randomness. I mean, like, they tried to do the same thing with with encryption, right? They tried to like classify it as weapons technology when encryption came out.
Yeah, military grade. No, it either works or it doesn't. Simple. No military grade. Either the crypto works and it has a particular strength, or it doesn't. That's it. There's no military grade.
Right. Let's last question, because we've got we have a hard stop coming.
We do have a hard stop.
There is a question on any thoughts on the Fed's Open CBDC pilot that claims 1.7 million transactions per second. So CBDC, for those who don't know, is central bank digital currency, and the Fed, as in the Federal Reserve in the US, the US equivalent of like the central bank, has done a digital dollar system.
It was actually developed at MIT, and the project is called Hamilton.
Is it?
Yeah. So yeah, this caused a lot of chatter a few days back. So I've been slowly digesting the paper. So I haven't had a full comprehensive read, but I think I've got enough to be able to kind of give it Eli 5, I guess. So like 1.7 million TPS it's not that high, right? In terms of these kind of systems. We ourselves have done 1.4 million. The guys at UCD that we work very closely with, Professor Sadogi and his team, they've done multiple different kind of consensus mechanisms with their ExpoDB platform that have achieved, in excess of 1.7 million transactions and stuff. So it's not really anything where we should be going, oh crap, it's like someone's really pushed the envelope here. What it looks like under the hood is it's just a bunch of different things been put together in a particular way to serve a particular use case that you would need for a central bank digital currency, right? So they're using Raft, it's a two-phase commit, there's some communication like virtual shards and stuff. There's this thing called an atomizer, which I'm not sure exactly what it's doing yet, so I haven't worked my way through that paper quite in enough detail. I've got some confusion stuff, but basically you've got these different components, and the test that they ran, there was some component that creates a bunch of transactions and stuff, UTXO based, which was quite interesting. And then that gets fed into the atomizer and the validators and stuff. They did their thing. They use Raft consensus, two-phase commit. Some of the synchrony going on as well, which is quite interesting the way that they're doing that. But again, it's nothing where we should be going, oh my god. But what did strike me as strange was that the test configuration seems a bit, I don't really want to say dubious, but so basically there was like 3 regions in America where they had, so they had 3 geographic regions, all within the Northern American continent, so not global, just within in the US. And from what I can, unless I'm reading it wrong in the paper, and I've read it a few times just to be sure, it seems like there's only like 3 or 4 machines in each of these regions, so very low numbers of machines interacting. They're quite close in terms of geographical distance, so not really surprised that they've been able to stump out a high number like that using the technologies that they're using, put together in this particular way when their test configuration is really quite small. So, but then obviously, if you permission networks, you don't want thousands of validators. The less you have talking to each other, the faster you can go, basically.
Right. I mean, it's a permission system. It doesn't it doesn't seem to be BFT, right?
What?
BFT, Byzantine fault tolerant.
No, it's still there because we've got Raft in there.
Okay.
So you still need BFT because even though they're permission, they can still fail, right? They can have crashes, or somebody neutrinos can come in and mess with the RAM cells or whatever. So you still need some BFT, and if their internet connection goes down, whatever, right? You still need that. It's just that in permission systems, you're not usually dealing with adversarial failures. You're just dealing with hardware failures and stuff like that. You still need it.
Right. And the other thing I'd say is Alipay did a test of their payment system of 1 million transactions per second.
That was a while ago.
Which was a while ago. And the last China, I can't remember what it's Singles Day, they did 800,000 transactions per second in actual transactions. And so these are payment systems that are already up and running. It's cool. But it's
there seems to be some interesting thought processes behind the way they put these things together that are quite interesting. There's nothing so far I've read that's really relevant to us. But then it's a centralized system, right? It's permission. So if it was permissionless and they'd rolled out 1.7 million TPS, then I'd be taking a lot more notice, right? Because it's oh wow, okay, someone's done something comparable to what we have done. Let's really dig into this. But 1 million, 2 million TPS on a permissioned low replica count system, nothing to really get worried about.
I think we'll stop there for the day. Thank you so much, Dan, and thank you everyone for your questions. We will be compiling some more for a couple of weeks' time, so please do keep asking them in Telegram. And
I messed this one up because I was answering them over the past few weeks, so we didn't actually have many that weren't answered. So it's just my fault.
Awesome. All right, guys.